Chata,
Okay.
yeah, go ahead, please, Chata.
You see my screen? I have a very
Yeah,
busy
it is
screen.
there. Yeah, notes on resilience. Yes, go ahead, please.
Okay. Okay. I'm sorry. I have a weird. I didn't create like slides, but it's more like a slide deck.
It's good.
I mean, it's a Word document. So this is welcome everybody. This is Çağatay Büyükkoç. I am one of the vice chairs of Open RAN group of IEEE. And I am also the founder of ORAN Alliance. And I work as a principal architect in DT. And I'm also a professor of computer science in Ostim Teknik University in Ankara, Turkey. So what I want to share today, and I really would like to have an interactive session here, a talk on and discussion around resiliency. So I see that everybody talks about resiliency and everybody actually means something else. So it's time to put some kind of definition on resiliency and some kind of, not only definition, but also how do you achieve resiliency? So it's a concept that is duly noted in many architectural groups, but not really discussed how you are going to achieve resiliency. So this is my attempt to put some discussion within IEEE community and also in other communities, and then how you would like to discuss and then define what resiliency should mean, right? So I start with, as you see, a black swan here. This is a picture I took in a very nice park in Ankara, Turkey. So why there's a black swan in this picture is going to become clear in a second. And so the general definition of resilience is it's actually coming from an Italian term to bounce back. So we would like to have the system, the ability of the network or system to provide and maintain an acceptable level of service under any condition, right? So if you have, so I'm going to define the conditions under which resiliences should hold in a second. So the general idea here is that resilience has two components. One is to provide, maintain, and provide service quality. So basically, what this means is that there are things that happen and that can be quantified in probabilistic terms, right? So, and then you would like to have those capabilities and then service quality maintained throughout your operation of your network or system, right? So this is the kind of one component of resilience. The second component, I am wondering whether Ashutosh, is my voice coming clear?
It's good. We can hear you.
Okay.
At least in the room we can. Hope people on the Zoom should be able to. Yeah.
Okay, thanks. Okay, the second component, which is basically where the picture of that black swan coming from, is that things that happen infrequently or non-statistically, or things that cannot be quantified statistically. It happens once in a blue moon, but when it happens, it actually strikes, is like a big natural disaster or a big terror event or event that cannot be foreseen, but you still need to prepare for it, because if you cannot prepare for a system under those conditions, then you don't have a resilient system. So the question here, I mean, the way that we want to define is that it needs to have these two dimensions and set of capabilities that are coming to against you through like faults or challenges, and then you need to be bouncing back, and you still continue to serve under those conditions. So this is basically the major impetus of this talk, or of this presentation, and why and how I'm going to try to explain in a second. And so here in this picture, okay, so let me try to make this a little bigger. I have, this is basically a loop of every network or every system, how it's a loop how every system or network operates. Every system is kind of a very term that is a little bit wide and general, but I will try to explain why. So the networks in general have, so I put here some numbering scheme, 1, 2, 3, 4, 5, but I'll try to explain this loop. So this loop shows that in networking jargon or networking terminology, you basically have a set of orchestrators. In ORAN terminology, this is called SMO, or management and orchestration, or service management and orchestration, which basically does the orchestration of services, and then also collects all the information and provide policy and other capabilities to the underlying system. So SMO is a key component of the network, and then you always will have set of controllers. Controllers are going to be controlling either network storage compute or all kinds of applications. In ORAN terminology, you have RIC controllers, near real-time RIC, and then that actually connects with the SMO, where you have the non-real-time RIC. So this is the ORAN terminology, but it doesn't matter. So in other networks, you always have controllers, and then these controllers actually make sure that the network services and devices on the underlying systems have actually the correct parameters that actually operate with. And then under that, we are following the loop here. And then you have a set of network devices or elements that collect data, that actually executes these commands, but at the same time collect data. And then once you collect the data, as you know, is nowadays the golden egg that actually provide everything. So unless you have data, you don't have anything. So once you have the data, you have to exert some analytics on the data. And then here we put a conceptual resiliency controller. So what this does, basically it collects all kinds of information. As I said above, that you have maintaining service quality, you are making sure that you are providing your customers the SLA performance requirements that actually that you promised, and also other things. I will come back in a second. It is basically a data analytics engine, which we are also hoping to achieve through some AI ML components within that. And then once we do that, the main question here is that the resilience controller at the same time is going to be aware of things that might not be working correctly. So if you have a state space of, let's say, working correctly, meaning green, and then once in a while things are kind of going out of the loop, and you recognize that something is not accurate, and then you need to make correct adjustments or changes. So that's basically the idea here, right? And then once you do that, you have to feed this back into the SMO through either data or the correct policy adjustments. And then basically this is the completion of the loop. So I am going to pause here for a second and see whether there's anybody has any question about this loop and what I discussed so far. Okay, let me pause here for a second. Okay, and this is supposed to be an interactive section. And if you can please, let me put here a little, this is me saying hi. Okay, any questions or any comments to this?
Hey, Chata, this controller, do you have different levels of controller like?
Yes, absolutely. So actually we have, as you know, we have basically in the system network jargon, what I mean in the RAN, you basically, you can take this as a near real-time RIC as a controller. But in other, you might not have that, but you can have CU-CP, which is controls the CU control plane functions, or you can have a completely storage network, and you have basically storage controllers or compute controllers, or you have some applications. So I kind of put this like a lump sum word controllers, but there are too many different types of controllers that execute in the network.
There's a raised hand from Rajesh Murthy. Rajesh would like to ask.
Okay, go ahead, Rajesh.
Hi, thank you, Karate. Can you go back to the definition of your resilience, please?
Okay.
So, is your approach considering A as reliability and B only for events that are not that are unknown?
What is B? I got the A, but I didn't get B.
Okay, if you can, B is, you're saying challenge preparedness, and
Yes.
you're talking more of some kind of a non-statistical or a black swan events.
Yes.
So events that are tangible.
Yes.
So I'm just trying to understand these two. You seem to be talking more from a reliability perspective.
No. Okay. Just can you hang on 1 second, because I will come back to define each of these in detail, and like what is maintained service quality and availability, reliability, and all these are components of that. people mix reliability as resiliency, which is not correct. So we are trying to do here as a much more generic or general definition of resiliency. So can
Okay,
you?
thank you
can
for
you-
that. And second part is when you say challenge preparedness,
Mhm.
are you speaking in terms of tangible or intangible?
I will,
In
I will-
terms of,
yeah, I will define them in a second. Can you hold on 1
oh
second?
yeah, sure. All right, thank you.
Okay.
And Kagate, would you be making this available to everyone?
Yes, I will.
Thank you.
Okay, so let me, I guess there are lots of questions because it is a lot of discussion in the industry around
Tata,
resilience.
you want to reduce, we cannot see your right-hand text at all for some reason. Yeah, I can, yeah.
Okay.
that's-
This meeting is being recorded.
Okay, so let me quickly, I guess time is also running out, and let me quickly go through what we mean by each of these components: maintain service quality. This is a set of capabilities that are needed and expected by SLAs. And mostly this is the set of capabilities that people understand when somebody talks about resiliency, because it has most popular concept is like performability, is the set of capabilities that determine the degree of satisfaction of the service. Availability is the readiness for usage, for which the probability the system will be operable when needed. Or reliability is the continuity of service. The probability of system remains operable under a certain specified period. So these are pretty much, and then we also have maintainability, is the ability to undergo repairs. So we are trying to put together a set of capabilities under this category, maintain service quality, as a component of resilience. So, and then this is a big one, AAA and security. AAA is, as you know, is a key component of networks, and then security also is a key component of networks, and then you cannot have a resilient system if it's not secure. So it is a really big component. And then for security, people have different understanding of what security is, and then I'm not going to try to define it here, but in Oran we created a work group under security, so it's a big working group under security. And IEEE also have a security group, working group, and other HC and other standards bodies, 3GPP, etc., have lots of security related activities. So this is the first big component. The second big component is basically the challenge. You have to be prepared for challenges. And what are those challenges? So those challenges are things that happen infrequently or happen, on a non-statistical, because it's not predictable. And you have to have survivability. And survivability is the capability of a system to continue functioning in the whatever threat there is. Basically, the definition of resilience coming from, you are going to bounce back. You are not going to go lie flat, right? You are going to bounce back. So whatever there is, so we want to have the set of capabilities that will make you bounce back. And fault tolerance is one of the things that it is discussed in the literature. and you have lots of service failures, etc. And this might happen because of hardware or software or many other reasons. So it's kind of a and usually it is not accounted very well beforehand, but we are trying to figure out how to manage those. Disruption tolerance, when you have a system of connected components, and then you might have connection problems, or you suddenly have a disconnected system. You all know the CAP theorem, etc. So I don't have time to discuss those things. But disruption tolerance is a very big, component of this challenge preparedness. And traffic tolerance. So that in certain events, you might have, whether because of too many people rushing to a particular area or a event, and then suddenly you have a huge traffic overload, and then also there might be unpredicted or unforeseen attacks that is coming from malicious sources. And so these are kind of other components. There are actually there might be some others that are not accounted here, but I am assuming that I'm giving an idea of what these black swan events are. So these are not things that are unforeseen, right? Okay, and then so the resilience controller or resilience manager. So I have defined above like two system components that will collect data and then try to address to various events. Some are foreseen, some are not foreseen events, and then make sure your system continue to operate under any condition. So, and then, okay, so let me try to, okay, so let me just end this little presentation. To realize resilience, we need to express resilience in terms of characteristics of the network, right? So if you cannot measure something, you cannot control or manage something. So the idea here is that we are assuming that we have a way of collecting data and then making sure that we understand what the data means. And then analyze it carefully. Now we have very good tools of AI, ML-based tools that makes this help human beings with the making decisions, and then address to these two different components of resiliency. And then because the first part is that when you provide a service to a user, you usually address or sign an SLA saying that, okay, your service quality will be, etc. Okay, and then either business or user or consumers, you have this type of SLA. For unforeseen events, you still can provide SLA and says, okay, under specific disaster scenarios, I will make sure to provide and then continue operation following this, right? So this basically the set of components for resiliency. And then there are two components here, two related concepts that I did not discuss today, but I guess we need to discuss it within IEEE at some point, because it keeps popping up everywhere without people meaning what it actually means, because there is no way of measuring it. So one is complexity, and the other is robustness. So complexity and robustness concepts are tied together, and we have a very good way of how they are tied together. And then hopefully we'll have another session sometime soon to discuss those things. So basically, let me just show you one more picture, and then I will stop and then ask some, if you have some questions. So here is a conceptual picture of a system, and then on the horizontal scale, you have three operational states: normal, degraded or partially degraded or severely degraded state. And then in a vertical state, vertical parameter, you have acceptable, impaired, or unacceptable states. So basically, you can say that any system can be either red or green, or somewhere in between, right? And then our usual paradigm, or our method operation of that loop that I just described, is instead of going through the following, this, if something happens, you go from normal and degraded, partially degraded, and then this set of states, because of your ability to address the questions in time and then take care of whatever needs to be taken care of, you are basically creating a different trajectory to making sure that the system will survive or bounce back under a great variety of conditions. So basically, I'm going to stop now and then ask people if you have any questions or any suggestions of how this can be realized, and then we can discuss or forming a group of I mean, I have lots of ideas how this can be achieved, but I'm bringing this to your purview here. Okay.
Chata, I'm so happy you addressed this resilience part. I mean, nowadays the measure of resilience is just like we say MOP, right? I mean, or MOS score for audio videos thing. The measure of cyber resilience is important. I think you address many of those pillars that will contribute to the resilience factor. I was thinking, I mean, this looks like an interesting, important area to focus. We can take it as a task item within Open RAN industry connection working group, right? We meet monthly. And yes, question. I think Scott has a question. Go ahead, Scott.
Kagate,
Hi.
I put a couple of
Wait.
it's Rajesh again.
But-
I put a couple of references on the chat. Those two would be useful. And in the Reliability Society and the CIS, the Computational Intelligence, we are planning to probably open a standard on resilience, particularly given the critical infrastructure importance. From a perspective of, maybe we can take it offline as well, it can become a long conversation. We need to consider, for example, how we are going to be doing the outliers, anomaly detection, and sensitivity analysis as well. Those would be useful, and they need to be done at multiple levels. And this is one of the questions I had yesterday when they were presenting intent-based networks. So this is, given the complexity of the topic, I believe it was very well presented. Thank you for this. It is a complex topic. And yeah, I look forward to working with you outside of, when you start the group. So
Okay.
please keep me in the loop. Thank you.
Thank you very much also, Ashutosh.
What's
I
your name?
cannot,
Sorry, can you put your name in the chat? I just want to, I'm taking notes. Scott
Ashutosh,
has
I
a
was going to say, do you have the capability of capturing the chat window comments? So
And they'll be all saved. All chat comments will be saved anyway.
okay.
Scott has a question. Scott Boreski from and Dilip also. Yeah, go ahead, Scott. Is it not?
Hello?
All right. Why don't you use this wireless? Yeah, hold on, please.
The mobile microphone. Can you hear me, Chita?
Yes.
Yeah, all
Clearly.
right. Hey, how are you?
Hi.
So this is, that's somebody tapping on another microphone. All right, I think we're ready now. So, hey, Chitai, Scott Paretsky from Ericsson. Good to hear all as well. Very interesting work. Certainly the tie between security and resiliency has been identified in a couple US agencies. Most recently, the FCC CISRIC report from Working Group 3, which I contributed to, talked about the tie between security and resiliency for 5G cloud virtualization. And then also the ONCD in their national cybersecurity strategy talks multiple times in the document about the tie between security and resiliency. So I'm glad that you're addressing that. And I like this diagram here that you're showing. I do have 3 yes or no questions for you to help bring this to the scope
Okay.
of IEEE.
Okay. Black and white.
The first one is this architecture diagram general to RAN?
Well, I did not mean this to be a general to RAN, but it's kind of a generic diagram that would hopefully include the core networks and other parts of the networks that constitute an end-to-end network, right? So it might be an overly simplistic in that sense, but if you see this under controllers, for that reason, I put here like storage, compute, network, applications. So just to make sure that this is like a generic loop. So if you would like to help us to create a more...
I have more yes or no questions before I commit to.
Okay. So this is...
Have
this
you
is not
taken this
Yeah.
to the ORAN Alliance?
I hopefully will do that, but I want to see like a general pulse of the industry before I do that. What do you think?
If we do this within IEEE, are we creating a competing Open RAN architecture?
No, I don't believe that we are competing in any sense. And so let's take it offline.
I don't think we are competing, no.
Yeah, we are
This is
not.
an alternate architecture.
Yeah.
Alex, are you still on the call? Alex, to talk.
Yeah.
Yeah, I'm on the call, may I?
Alex, there's a question about if you follow through this architecture as part of PAR or whatever task group.
That's exactly what I wanted to suggest. I think that Chatai presents a good vision. He sees far beyond the architecture. People here are qualified to identify specific issues. But however, I would start from the top. I would suggest that you think of a framework, resilience framework for networks, for RAN, whatever you decide, how you want to narrow it down, make it generic or make it RAN completely focused. But I would suggest that that could be a very good IEEE standards. We don't compete with anybody. We are just a component factory. Whatever standards we do, you give it to ORAN. I mean, you do it for ORAN and give it to ORAN. You can
Okay,
standardize.
So
I hear
let's,
that.
let's move to other two questions, Scott. So this.
I
you
have one
asked-
more important question. Is there any IPR associated with this?
No, because so far the IPRs can be associated with the contents of those boxes. So actually, I am thinking of unless you define what are you doing in those boxes, there's no IPR. So you cannot develop an IPR on a loop, a generic loop like this, right? Unless you define what you are going to do with them. So far there is no IPR, but you know, as you cleverly note, if I can say, I'm going to do this to the net, to the data coming to me by this way, that's an IPR. What is inside this box or this box, right? So far, it's not.
Good, thank you. I'm all set with my question.
Thank you, Scott. Dilip, you have a question? We have another question from the audience here.
Okay.
Hi, this is Dilip Krishnaswamy. Hi, a very nice presentation. Some existing capabilities, like, you know, for example, in OCloud, if you use containerized workloads, they have self-healing capabilities and all that. So I suppose your architecture will leverage any available resiliency in systems and then complement on top of that.
Absolutely. I mean, so look, so the SMO here and all the underlying OCloud functions, or as defined by ORAN, that is connected by O2 interface, that are they are all part of this loop, right? So I did not specify each of those one by one, but the understanding is, you know, either the controllers or the, you know, SMO or the data analytics collect all the relative data and then share it using one of the key interfaces, O1, O2, E2, A1, etc., to disseminate the information and make sure the proper actions are taken place, right? So is that the nature of your question? I am actually, who asked the question? I'm sorry, I missed.
Oh, Chatai, this is Dilip.
Oh, hi, Dilip. Oh, good, excellent.
Hi.
Okay, I hope I answered your question.
Yeah, Chatai. Thanks, very nice. Thanks.
So Chatai, I think I know we have to move on unless anybody else has question. So I would suggest and also ask Alex to give his comments. You want to add new things to it, then we can discuss it in our next monthly meeting as a way forward, and maybe take comments from people who listen to the presentation today. Alex, you have any suggestions? I mean, the overall framework comment is good. Go ahead.
No, I suggest that you do target a PAR. I mean, it depends on you, on Chatai, and everybody who will follow him in the definition of the PAR, in the scope of the PAR, how generic you want to make it, how narrow, or whether you want to make it a standard or even just a recommended practice. But so that's where you have to look at. But to me, this is a very good candidate for a IEEE standard, specifically dedicated to, or I would dedicate to ORAN.
Absolutely. We have another small question from Ushman.
Yes, sir. The name is Usman Goni. I from Nobilis Inc. and work with Homeland Security. So, you know, it's a great feature, you know, for ORAN certainly, but in the more physical world, the context of having resiliency is something that may have a cost function to it. Of course, the same thing in the same environment. The question is there any cost related function that we would now look at it as a flag to say, well, the more we build resilience into this, of course, the better. But at some point, that resilience becomes now a cost function that we cannot go above certain level in terms of the capability that we have to build into the system. So with this model, address some probabilistic numbers or something that would say, well, you know, if you get to this point, it's sort of a diminishing return in terms of overbuilding the capability.
Okay, okay. Actually, this is a good question, but I have already put some thought into this. So I don't know whether probably you missed the end of it here. So there are two concepts that are related. One is complexity and one is robustness. So how, because you cannot have a system that is robust without any complexity in it. But after, you know, every complexity measure you introduce to the system, basically as a way of providing either resiliency or robustness, brings in some cost and also brings in some complexity. Complexity basically can be measured in some way versus with lots of things, but also as cost. And then I don't know whether you know this famous book called Anti-Fragile. So the system becomes fragile after a point because you have introduced so much complexity that actually becomes an very easily broken and so very high level of cost. So our purpose is to determine the minimum set of capabilities to make the system robust and cost compatible, so that it is providing you cost performance of what you are aiming for. You are absolutely right. So everything has a cost to it. And then as you increase the complexity, cost increases, and then system becomes fragile and then too complicated and easily broken. So anyway, so I'm going to stop here. I think, I don't know whether I answered your question.
And I think the answers are hidden in your complexity thing. So, I mean, at this time, Chata, I think as Alex was suggesting, we take it to the next step and what else we can add. I'm sure this is your initial draft. You may like to add a few things based on the comments we got today. That any last minute question? Otherwise, we'll just take a 10-minute break. Just come back to listen to the other candidates. I hear none. If I'm not at my laptop, if you have any question, I'm not watching if anybody raised their hands. Are you speaking, Purva?
Yeah, so there are a couple of questions. Just give me.
So Chata, if you can answer those questions in the chat, we are capturing all the questions in the chat anyway, because we have other items also need to discuss. This is an important one.
So there is one question actually from Samantha. Chata, if you can read that question. She's asking that with reference to building resiliency into systems and networks, are there elements of zero trust we can build as an approach in organizations?
Okay, I think in our so this is a subset question. I mean, security is a very big subset of this resiliency question. And then, as you know, this zero trust architecture is basically very fiercely discussed within security groups across the world, and especially Oran.
Yesterday, Scott also presented nice security zero trust thing.
I am assuming that we are discussing that within the corresponding bodies. So
yeah.
And there's one more question. I think this is from Bhupendra Kumar. He's asking like similar things happens in SDN and NFP service provisioning. how are the things related to RL ops used in Open RAN?
How are they related to what?
How are things, how the things related to RL ops used in Open RAN?
Okay. So, I mean, so RL ops, we have discussions within operator space and also in other vendor space. And I see them, these are all related concepts. So I think one way to address all this is to bring together the set of vendors and operators and then say, okay, do you want to solve this question of resiliency this way? Or if so, how are you going to be collecting data and how are you going to address the state changes? And then, you know, there are lots of things I left out. So for one critical thing is actually root cause analysis of data analytics and how you are going to do that. And I think those things needs to be discussed further. And I mean, this was just scratching the surface of the problem, and hopefully we'll have a discussion around that. So.
Thank you.
One more thing, Shatai. I think as Ashutosh and Alex mentioned that we are going to go with PAR for this particular document idea. So I think you'll need the PAR form. What I'm going to do is like, I'm going to send you this whole project authorization request form so that you can start filling in that information itself so that it's easier for you. You don't have to prepare one document and again try to import it into the other document since the target is the PAR.
Okay, let's discuss. So I'm not sure what are the next steps and where should we take the next steps to. Let's discuss, okay?
Thank you, Chata. Thank you for your useful contribution. Look forward to seeing you soon. And,
We don't get any gifts from you, Ashutosh?
you get a special gift. You're the vice chair too, right?
I'm joking, I'm joking.
Unfortunately, I didn't have any gifts for any of the RRSA participants today.
No, I'm
But
joking.
you'll get something. I think we'll just take maybe 10-minute break, folks. First of all, I'd like to thank you, Chata. And you're a contributor.
I thank you, everybody, for. So, is the video, is the you know recording going to be available? People are asking me.
They'll be all available, and we can also itemize each talk, so that way it'll be, you know, and the text and everything. So our APL, Johns Hopkins APL AV folks, they're going to do that.